is Mike Onako. Here I'm about to explain how primitive and reference data types are managed and accessed in memory. So talking about data types can be explained as the different sizes and values that can be stored in a variable. So this is to say that they define what kind of data a variable can store, or what kind of data can be stored in a particular variable. So data types has two main categories, and they are the primitive and the reference data types. The first one we are going to talk about is the primitive data types. These ones, they hold actual data which are stored directly in the stack memory. And so examples are the int, the float, the character, and then the boolean. These ones, they are fast to access and also they are small in size. So the next one we are going to talk about is the reference data types. The reference data types are more complex compared to the primitive data types. These ones, they hold the memory addresses. So the variable doesn't hold the actual value, but it holds a memory address pointing to where the value is stored in a heap. So it is something like a link that takes you to the actual content. So examples are the arrays, objects, and then strings. And these ones, they are accessed through a reference. So next we are going to talk about the memory areas. The memory areas in Java are divided into two main parts. These are the stack memory and then the heap memory. First, let's talk about the stack memory. So the stack memory is used to store primitive variables like the character and then the integer. So the stack memory is also automatically managed. So when the memory wants to be accessed, the method is called, then the variables goes into the stack, and then when the method ends, the memory is also released. So let's go to the heap memory. The heap memory is used to store all actual Java objects created with the new keyboard. So this is where all the larger complex data like the arrays and then class are stored, or they are kept. So in Java, a garbage collector is a feature used for automatic memory management. So unlike the stack memory where the memory is automatically managed, in the heap memory it uses the garbage collector that runs through the background, and then it removes all the objects in the heap that are no longer being used or they are no more useful, so that it will avoid memory leaks. We're going to talk about how data is accessed in the memory. How data is accessed in the memory in Java depends on whether the data is a primitive or a reference type. So first of all, the primitive type, how it works. So for a primitive like the int, which x is equal to 10, the value 10 is stored directly in the stack. So when we use the variable x, we are directly working with the value, which is the 10. But for the reference type, like the person p is equal to new person, the value p holds the memory address so that the address points to the actual person object which is in the heap. So when we use the p, Java first looks at the address and then the address which is in the stack, and then he follows it to the object which is in the heap. So you can see that with the reference, it takes a longer time than the primitive when the memory is being called. This is a diagram that shows how Java handles memory for both the primitive and then the reference types. So on the stack we have a primitive variable x which directly holds the value 10. Under that one we have a reference variable p. This one, it doesn't hold the object itself but an address where is shown as the 0 times 1a 2b. So this address points to the actual person object which is stored in the heap, which is under. So when we access p, Java looks out for the address in the stack and then it follows it to find it in the object p. So this shows the difference between the primitive values and then the reference value, how they are individually accessed. So in summary, the primitive types in Java are simple and then they use direct memory access. So these ones, they are stored in the stack and then they are accessed quickly. But with the reference, unlike the primitive, this one, they are more complex. They store memory addresses in the stack while the actual object lives in the heap. So by understanding the primitive and then the reference, we are able to write more efficient programs, and then we know how memory management and then how memory are accessed between the both of them. Thank you.